Here's an example of a data set without skew, and here's an example of a data set with skew. So it's whether or not it's a bit lopsided when you plot the data. So 2 ways to calculate it. First way, looking at quartiles. If we look at the normal curve, the upper quartile will be about here and the lower quartile and the median. So that would give the middle of a box plot looking like this. With a positive skew, that's where that's been pulled out to the right. We're going to get the lower quartile here, median here, and upper quartile up here somewhere. So that's going to give a box plot looking more like this. With the negative skew, we've got the upper quartile and the median quite close together, and then the negative skew, so it's been pulled to the left. Lower quartile down here, so that would give a box plot looking more, oops, no, not like that, that's the same as the other one, didn't mean that. Looking more like this, with the median closer to the upper quartile. So you can kind of see, and I use the whale's tail to remember this one, so this looks like a whale, there he is, and that's his tail. Wherever his tail is, that's the skew, so his tail is on the left, that's a negative skew, and we can calculate it by comparing Q3 minus Q2, that's that distance, and that's going to be a lot smaller in this case than Q2 minus Q1, which is this distance, which is a lot bigger. This normal distribution, that's not even a whale. Q3 minus Q2 equals Q2. This distance is the same as this distance. That's not a whale at all. It's more of a hill. I've got a whale here going in the other direction. There he is. And there's his tail. And the whale's tail is on the right. So that's a positive skew. That's where the tail is. And you can calculate it by comparing Q3 minus Q2, upper quartile minus median. That's that distance. And that's going to be a lot bigger now than the smaller distance, Q2 median minus Q1. So that's how you calculate skew when you've got quartiles. Here's a set of data I made up, 1, 2, 3, 4, 5, 6, 7. And the median is 4, because that's in the middle when they're in order. And the mean is, I don't know what it is actually, but 1, add 2, add 3, add 4, add 5, add 6, add 7, divided by 7. Something. The mean is something. Now, if I change the 7 on the end to 70, then the median is still 4, because it is still in the middle when they're in order. But the mean is going to be much bigger, because if I do 1, add 2, add 3, add 4, add 5, add 6, add 70 divided by 7, that's going to be much bigger. So the mean has moved. The median doesn't move, the mean has moved. And we're going to use that to calculate skew when we've got mean and median. We're going to look at the comparison and see what the skew is. So in a normal curve, the mean and the median, they're both in the middle. In fact, they're the same in a normal distribution. The mean and the median are exactly the same. When we have a positive skew, it's like when we've made that 7 into a 70 and stretched it out to the right. The median won't really move. Well, it won't move at all, actually, if we only change one thing. But the mean is going to be pulled over. So you're having a look where the mean is compared to the median. In the negative skew, if we make the smallest one really small, it won't affect the median. That will still be the middle value, but the mean will get pulled down to the left. So you're looking at where the mean is. So look at your median and look at your mean. And if your mean has got much bigger than your median, then your mean has been pulled to the right. And if your mean has been pulled to the right, that's a positive skew. Whereas, if you have a look at your mean and you see that it is much smaller than the median, then, or even a bit smaller, then you know that your mean has been pulled to the left-hand side, so that's a negative skew. See if you can use those 2 ways of evaluating skew here. Firstly, we've got mean versus median, so have a look where the mean is, that's the way the data's been pulled. And then we've got the one with the upper quartile, lower quartile and medians. So you can think of it using the whale's tail if you like, or any other way you choose to remember. Pause the video, have a go and then unpause to check your answers. So the first one's fairly easy. The mean is smaller than the median, so the mean has been yanked to the left, so that's a negative skew, looking at where the mean has gone. It's gone left, so that's negative. In the right-hand one, you have to actually do some calculations. Q3 minus Q2, that was 0.8, that's smaller than Q2 minus Q1, which is 2.3. So our box plot looks like this, which means our whale looks like this. His tail's on the left. That's a negative skew. And in the exam, to show, because obviously drawing a whale isn't really a mathematical method, to show that you understand why it's a negative skew, you would say Q2 minus Q1 is bigger than Q3 minus Q2, all the other way around for a positive skew.